Hi, I'm Felix Perez. I will be speaking about the energy yield calculation model of pvDesign today. I'm the last one today standing between you and dinner, so I'll be brief. So before starting, this is our first time in this conference, and we are very excited to be here. I wanted to introduce RatedPower and pvDesign as a company. So RatedPower was founded in 2017, and that's when we released the first version of pvDesign. We are based in Madrid, Spain. pvDesign is software for the automation of basic engineering work for utility-scale ground-mounted PV plants. You start by uploading your parcel definition. You define some basic parameters like equipment selection, pitch, number of modules per string, etc. And you get layout, a very detailed electrical system design, and a lot of documentation. Over time, we have been doing lots of continuous improvements of the software. So for example, in 2020, we released our bifacial calculation model. And well, just to finish off with this slide, in 2022, we were acquired by Emberas. Emberas, it's the largest SaaS company in the energy sector in the world. And we are very happy to be part of that company now. And finally, pvDesign by the numbers. Today, we have over 200 customers, 30,000 active users, and more than 100,000 simulations are run per year with the software. So in this presentation, I'm going to do a brief introduction to calculation model. Then I'm going to speak about our bifacial calculation approach and a couple of case studies. So the calculation model itself, it's the initial aspect is irradiation handling. We have a very simple transposition model using the Perez transposition. We have linear shading for the front face. We also have a diffuse shading model using the volt with the integration. Then the ground reflected irradiation for the front face is using a view factor model nowadays that we introduced that after the bifacial model. And we also consider the far horizon profile. In terms of the electrical model, we use the parameters from the PAN file and the OND file for the standard one diode model and the inverter model, respectively. We also have the MV system and transmission modeling included, and we also include the power factor calculations into the system as well. Power factor is considered both in sizing the system and also in how it affects the energy yield. One aspect of the pvDesign approach to this is that because the software automatically calculates the layout and the electrical system, we feed all of that into the energy yield calculation model without user intervention. So users only have to set basic energy yield parameters such as degradation or soiling, quality, etc. But the part where the electrical system is translated into the energy model, that is done automatically by the software, and that helps making the experience easier, right? And that is something that will be showcased in the case studies. So the bifacial modeling part of the calculation model, it uses the view factor calculation based on the Enrelance and the papers. It is a standard implementation of that. The only particularities is that we include the torque tube in the calculation as well, as you can see in the lower picture. And we also include the EIM loss. So that's we take that from the PAN file and we use it in the calculation as well. So yeah, we run some analysis to see if it works in the same way, and it does. I will show you that in the next slide. But we also did things a bit differently in terms of the losses. We have this picture that I'm showing here is a screenshot of the energy yield report in pvDesign. And we have a few more losses than other examples. So we wanted to have a bit of a higher granularity, let's say, in terms of how we report losses here. And that red line represents the transition from typical transposition to a view factor calculation. And well, it allows you to evaluate the characteristics of your system in a better way, and also to evaluate the impact of certain decisions, such as increasing the minimum ground clearance or how pitch affects the calculation, right? Yeah, and you can also see the presence of the EIM loss or soiling. We also have backface soiling implemented. So that's useful for this aspect. And finally, these are the analysis I was saying earlier. This matches what we found in the literature in terms of behavior of the model. As you can see, as GCR increases, bifacial gain decreases. This is for trackers. And we also have behavior relating to minimum ground clearance. And well, it increases in a parabolic kind of way. So then I have added a couple of case studies showing some other things that pvDesign does, which are similar to it. So degradation in pvDesign, we derate the module production for each year, and then we run every year separately for as many years as the user wants. So if the user specifies that they want to simulate 50 years, we can do that. And we run the full calculation model for each of those years. And you get that in the reports, for example, in that table. But it also allows you to observe some predictable behaviors, but it's good to be able to quantify them, right? So for example, you can see in the chart on the left, we have the overload or clipping loss over 25 years with increasing DCAC ratios. So it's clear to see that as the years go by, the loss itself gets lower, right? And we also have a very simple curtailment loss implementation, which is just a cap on energy yield. So if the value is exceeded, that is removed from production and accounted for as a loss. And you can see that loss as well dropping over time as more years get simulated. Finally, I said earlier that pvDesign runs the layout depending on the parcel geometry, right? And you get to choose different parameters. Because pvDesign fits that automatically into the energy yield calculation, this allows you to do some more unusual studies very quickly using the software. So if you have a very complicated layout, you can actually run very detailed and deep studies using the software where you combine a layout generation algorithm with an energy yield calculation algorithm. So for this study, we made a complicated design, right? And we created batch simulations using GCR values, right? And we wanted to see kind of the trade-off between adding more power and at some point we would see losses to shading, right? And that's what you can see with the software. This is running a fixed tilt simulation. So as GCR increases, the pitch gets closer, we get more losses due to shading. And you can see very clearly where we have a trade-off and an area of diminishing returns between increasing peak power and starting to lose production because of that. And with pvDesign, you can find that point very easily and very quickly, right? And with great accuracy as well, because the software is running a very thorough layout algorithm with smaller structures. It can also consider topography and slopes. So this analysis can get very deep if you want to spend the time to actually set up the software to do it, right? And you can also see on the chart on the right, we have the specific production, and you can see how it drops as GCR gets closer, but we get more production because of peak power. And finally, this is just showing the production for each month, and the lines on the upper part of the chart are with higher GCR values. And you can see that at some point you start actually losing production significantly in specific months compared to the lower values. So that's all. Thank you so much.